All right, guys, this is the start of section 5.7. Now, CPCTC here. This is something you are going to want to know because it's very, very, very useful. Okay, but I want you to think about what it stands for. Don't just remember CPCTC because that tells you nothing. This stands for corresponding parts of congruent triangles are congruent. So C, P, C, T, C. Now every time I write this, I actually say it in my head, corresponding parts of congruent triangles are congruent. So give yourself a minute and say this over and over and over so it ingrains it in your brain because you do need to know it. All right, so corresponding parts of congruent triangles are congruent. So what does that mean? Well, let's say that we have these two congruent triangles, okay? And now think back to what it means to be two congruent triangles. That means every one of the sides on the left is congruent to every one of the sides on the right. That means every one of the angles on the left is congruent to every one of the angles on the right. Okay, so let's say that, let's say we prove this by angle side angle, okay? So say we just know this, angle side angle. Okay, so after we prove these are congruent by angle side angle, by using CPCTC, we could go one step further and say, well, since these two triangles, since we've proved these two triangles are congruent, then that means that this angle has to be congruent to this angle. Or maybe that means that this side has to be congruent to this side, or this side has to be congruent to this side. It's basically saying that because the triangles are congruent, every single part of them is congruent. Okay? Corresponding parts of congruent triangles are congruent. Now, I want to make sure we understand that we only can use after we have proven the triangles are congruent. Guys, if we haven't said that these two triangles are congruent, we can't use this because these pertain only to congruent triangles, okay? Corresponding parts of congruent triangles are congruent. All right, we just have one vocabulary word here, and it's indirect measurement. Now, anytime you measure something indirectly, it basically means that we're finding the measure of an object without physically measuring it. So we're using other methods other than a tape measure, other than a ruler, other than a yardstick, whatever, to measure objects. So think like you talk about people using the shadows of sunlight to estimate how tall something is. That would be an indirect measurement because we're not going up and measuring a skyscraper with a meter stick or with tape measure. We would use the sun's shadow to say, oh yeah, that's so many feet high or whatever. That would be an example of an indirect measurement. All right, surveyors actually use these types of methods for a while. So let's think of this. So it says the figure shows how a survey can measure the width of a river by making measurements on only one side of the river. So what it's saying is he can tell how wide the river is without ever crossing the river or without directly measuring across the river. Okay, so it says study the figure, then explain how the surveyor can find the width of the river presented by BA. Okay, so I want you to think about this and look at the diagram and ask yourself, how can we find this length here, which would be the length of this river, by using this figure? Now, if we look at this figure, if we make sure C is the midpoint of A and D, that would make this side and this side congruent. Okay, and if we think stakes or whatever that are perpendicular, and guys, wouldn't this be vertical angles here? So wouldn't these be congruent triangles? And if these are congruent triangles, then I would know that this side is congruent to this side by C, P, C, T, C, by corresponding parts of congruent triangles are congruent. And I could physically measure this side without crossing the river. Okay, so now let's put that in a proof. All right, so we're given that angle A and angle D are right angles. Okay, so that's given. Okay, so what do we know about all right angles? Well, hopefully we know by now that all right angles are congruent, so angle A is congruent to angle D. And we have a theorem, it's called the right angle congruence theorem, that tells us all right angles are congruent. Okay. Now, we also are given that AC is congruent to CD. That's given as well. So we have an angle here, a side here. Okay, and looking at this diagram, we see that we have vertical angles here and here. So I could say that angle BCA is congruent to angle DCE by the vertical angle congruence theorem. Okay, now I have another angle. So I have two angles and a side, which is all I need. Now I need to look. This side is between the two known congruent angles. So I can say that triangle, scroll up a little bit, triangle BAC is congruent to triangle. Now remember to write these in the correct order. So BAC would be EDC by the angle side angle congruence theorem. Okay. Now that we've shown that the triangles are congruent, we can use CPCTC. Corresponding parts of congruent triangles are congruent. So BA is congruent to, well, BA is the first two letters. We should make sure to name it right. ED, which is right here, which is correct. ED by the CPCTC. Okay, so we're not really learning anything new. We're just going one step beyond triangles are congruent to show that all parts of those triangles are congruent as well. All right, so let's look at example 2. All right, so we have this diagram at the right, and it says that it was reported that one of Napoleon's officers estimated the width of the river as follows. Okay, so the officer stood here at the bank of the river, okay, and lowered the visor on his cap until the furthest thing visible was the edge of the bank on the other side. So he lowered it to where this matched the other side. So that, then he turned and noted the point without moving his visor on this side that reached, okay, which is right there. So we immediately know that this and this are congruent, okay. The officer then paced the distance to the point and concluded the distance was the width of the river. Okay, so we have a right angle. Because he's standing upright, he stands at a right angle. So right angle and a right angle. And then we know this and this are the same. And then think of he is shared among these two triangles. So what, maybe if I write it out over here. So we have a right angle, this, and then they share this side here. This is him. Sorry guys, these are not drawn to scale clearly. So what theorem could I use to show these two triangles are congruent? Guys, I could use the hypotenuse leg theorem. Don't forget the hypotenuse leg theorem, especially with right triangles. Okay, so I can say that these two are congruent, and therefore EG has to be congruent to FE, which is the length of the river. Okay, so then I jumped the gun, studied the figure, and explained how the officer concluded that the width of the river is EG. So yes, I did jump the gun. So we proved these two triangles are congruent, and therefore we can measure from here to here, and we know this is the same as from here to here. All right, let's do this proof together. This one's a little more complicated to write out. So I'm given that angle 1 is congruent to angle 2. That's given. Now, angle 1 and angle 2 are the exterior angles. So this would be angle 1. This would be angle 2. Okay. Now, how can I use that? Well, I can use that to show that this angle here is congruent to this angle here, but it's going to take a little work. Okay. So I can immediately say that angle 1, I'm going to call this angle 3 and angle 4 just to make. So I'm going to say angle 1 and angle 3 are a linear pair. And I can say that angle 2 and angle 4 are a linear pair. And that's just by definition of linear pair. Now, if I go a step further, we have the linear pair postulate, both of those are definition of linear pair, which tells me that angle 1 plus angle 3 equals 180, and angle 2 plus angle 4 equals 180 as well. So this would be the linear pair postulate. Okay, anything that's a linear pair is supplementary. That's what the linear pair postulate tells us. All right, so if both of these are equal to 180, then I could say that angle 1 plus angle 3 is going to be the same as angle 2 plus angle 4, because both sides are equal to 180. And that would be the transitive property. If you want to write substitution, you can. Okay, we'll now go back to what's given. Remember when we started proofs at the very beginning, I told you that anytime they're given that two things are congruent, think substitution. So let's substitute angle 2 in for 1. So I could say angle 2 plus angle 3 equals angle 2 plus angle 4. All I did here is substitute. Okay, well notice I have an angle 2 on both sides, so I could subtract an angle 2 on both sides by the subtraction property of equality. And then when I simplify this, I can say angle 3 equals angle 4, and that's just simplified. So I've shown that this angle here is congruent to this angle here. So that was the hard part. All right, now I also have to write that angle RTQ, so RTQ, which is right here, is congruent to RTS, which is right here. So angle RTQ is congruent to angle RTS, that's given. Okay, now I've shown two angles are congruent, and I notice that they share this side here. So I can say RT is congruent to RT by the reflexive property. Okay, now by angle side, I can say that angle or triangle RQT is congruent to triangle RQT is congruent to triangle RST by the, well, two angles and a side. The side is not between the angles, so it'd be angle side. And then from that, I can get QT is congruent to ST because corresponding parts of congruent triangles are congruent.